Yeah, hi everyone. Another session of Patrick Pathshala. Basically, ideally taking up questions that would help you to prepare for the exam, any aptitude examination. So, Quant will be focusing on the tricks, terms as to how to go about solving the questions. Right. Just a minute, I'll just start with the whole course. If you have any queries, questions, put in the chat box. Yeah. Perfect. So, if you have any questions, we can put on the chat box. The basic idea is taking up a few questions and discussing how to approach and what to go about solving as such. You need any guidance with regards to preparation, feel free to put in the chat box and I'll try to answer whatever queries, questions that you have. So, for whom is this session? Basically, it's a max session. So, it's max session. Mathematics is there in almost all exams, be it UPSC, be it MBA entrance exam, be it IPM, be it any entrance exam. So technically this is useful for anyone who is preparing for any aptitude examination which has mathematics in it. The idea and whatever is being taught will help you in any place, whichever you are useful. So that's what the whole idea is. Why the session is important? Because here I'll be discussing few shortcut techniques, tricks that will be important for you to solve the questions. And if you can learn those techniques and tricks, it will help you to solve things faster. So that could help you to do better with the examination. And these tricks can be solved in number of questions, not only one question. I don't believe in formulas which can be only used in a specific sum, but it should be able to use in any sum that are available on that aspect. So let's start with a question. So we take the first question and then I look at, try to solve whichever method you're comfortable, the traditional method, whatever method that is there, and I will try to tell you basically how maybe you could approach the sum in a better way or in some other way that is there. If you feel you have a good approach, do mention in the chat box and I'll try to help you off with it. Right. So first question, I'll give you some time, 1 or 2 minutes to think and try to solve and get the answer. If you get the answer, you can put in the chat box. So if you get the answer, you can put in the chat box. Okay, so let's try to understand. So a very important concept called a multiple. If you can understand a multiple, a lot of questions can be solved fast using a multiple. So let's look at how can we use multiple out here. So there is Lajvanti who is there, has twice as many sisters as brothers. That means the ratio of sisters and brothers is 2:1, right? Which means it's a multiple. Whenever your ratio means the total is 3, which is multiple of 3. Okay, if it's 2x, 1x, it's total multiple of 3. So including Lajvanti, it has to be a multiple of 3 plus 1. Yeah, she has multiple of 3 brothers and sisters. We want how many children that Shankar Lal has. So basically it will be multiple of 3 plus Lajvanti, multiple of 3 plus 1. Look at the option. There is only one option with multiple of 3 plus 1, D option. You can technically mark the answer directly. Multiples are a very strong or very good way of trying to get the answer quickly. Same, if I look at Bhola, he has thrice as many sisters as brothers. Right? So that means the ratio of sisters and brothers is 3:1. So total is a multiple of 3. Multiple of 4, sorry. 3 plus 1, 4. Total is a multiple of 4. And including Bhola, it will be multiple of 4 plus 1. Now if you look at the option, the only option which is the multiple of 4 plus 1 is 13. So that will be the answer. So multiples are a very good way of trying to get the answer quickly. So if you're good at understanding multiples, a lot of sums can be solved quickly using multiple approach. Right. You go to next. another way, another approach. So another way and approach that you can use to solve a sum. So here basically the logic is that whatever the value which are there, the answer in percentages, you can ignore these values completely. I mean, though the length and breadth is 3729, you need not take 3729. You can completely ignore these values because the answers are in percentage. You can just take length as 10 and breadth as 10 and solve straight away. Okay, because the answer in percentage, you can directly take length as 10 and breadth as 10. So if you reduce the length by 30%, it becomes 7. So you're reducing by 30% length. So the length will become 7. Same way, if you reduce the breadth by 20%, it becomes 8. So old area was 100, 10 into 10, 100. New area is 8 7 the 56. So reduction from 100 to 56 is 44. 44 out of 100 is 44%. C option is the answer. Right? I hope it's clear. Because the answers are in percentage, you can always assume value and then start it. Instead of taking 3729, and it's just given to confuse you, you can always start with 10 and 10. I assume length is 10 and breadth is 10. So I reduce the length by 30%, you will get 7. I reduce the breadth by 20%, you will get 8. So old area was 100, new area is 56. So reduction is 44%. That will be the answer in this case. Right? Hope it's clear. Now this is a little on a tougher side. I mean, I'm not saying difficult, but I'm just saying it's a tougher side. So just look at the sum and try to figure it out. Under what condition would we take? Look, again, I took the value because the options were in percentage. So the value doesn't make. So most of the time when the options are in percentage or ratio, you can assume values and go about taking it, solving it. Or you can always assume value also if there is no addition subtraction between. But normally in most of the cases you understand where to assume value. As in when you practice more sums, you should get a fair idea as to where to assume, where not to assume. But a lot of sums become easier if you can assume and get the answer. This looks difficult, but actually it is not. I mean, you can get the answer in note, you can get the sum orally, and you can get it in maybe 30 seconds as such, if you want, if required. Yeah. Sometimes the sum maybe could look difficult, but you could get the answer quickly if you can know the approach or know how to go about solving. Again, this is also something very common in the exam where you form a pattern. When there is large numbers involved, like in this case the large numbers involved, you then try to find a pattern and try to get the answer. Instead of solving the whole thing, obviously solving is very difficult, you try to figure out what can be the pattern that you can approach and then use that pattern to try to get the answer. So the idea of taking these sums now is also So you're aware about the methods, and when we practice later on, it should be there in the back of your mind. The moment you see a sum, you should know, oh, this is the method to use. So basically trying to reinforce the methods which are there as far as possible. If you can reinforce the method, it could help a lot with regards to, later period. So this is also a very common technique that is normally used called generalization. You try to find for one small value and then try to generalize for a larger value. If I am looking at solving this, you have 2 in the end out here, 3 in the end out here, 4 in the end out here. So first term ends with 2, second term ends with 3, third term ends with 4. So 2016 term will end with 1 plus 1 upon 2016 square plus 1 upon 2017 square. Right? Now let's try to figure out. If I take the first one itself, what is the value of first one? Root of 1 plus 1 plus 1 upon 4. If you solve, it becomes root of 9 upon 4 or 3 upon 2. Now, how do you write 3 upon 2 in one of these terms? I can write it as 1 plus half, but this number and this number has to be same, so not this way. I can write it as 2 minus half. Yes, 2 and 2 are same. Now you can generalize. Now when the last number is 2 out here, you can make out 2 minus 1 by 2. So when the last number is 2017, the answer will be 2017 minus 1 upon 2017, D option. So the pattern will continue. Whatever happens for one small number will also be there for all the numbers put together. So when you use the pattern for one number, in this case, I use only for the first one. I'll try for second one also. But when I look at the first one, when 2 is the last number, I get a value as 2 minus half. So 2017 is the last number, I'll get 2017 minus 1 upon 2017. I'll take one more and check out. See, if I take also 1 plus 1 upon 4 plus 1 upon 9, this becomes 36 denominator. Numerator becomes 36 plus 9 plus 4, which is, if you look at 49 upon 36 or 7 upon 6. So basically what we have is 3 upon 2 plus 7 upon 6. If I take 6, 9 plus 7, 16 upon 6 or 8 upon 3. 8 upon 3 is also 3 minus 1 upon 3. You need not do this, I am just showing it to you. Showing that it also works with higher numbers. So this is 3 minus 1 by 3. So when it was 2 in the end, we got 2 minus half. When I took two terms, I got 3 minus 1 by 3. So from that I can make out the answer is D option. So what I did was, whatever answer I got, I tried to put in terms of the options which are available to you. And putting in terms of those options, then I can figure out which is the answer easily. So 2 is 2 minus half, so 3 becomes 3 minus 1 by 3. And that gives you the answer. So, right, I hope it's clear. So approach is generalizing the sum and trying to get the answer. Right, pattern formation. And this is also very common in the examination. You try to form a pattern, you get the answer. The sum looks very difficult, but most of the sum with larger numbers are very simple to calculate and get the answer. Normally it will not come under very specific module. I mean, these are general pattern ways of solving it. So it is not there in a specific module. There are specific sums where this sum is normally used when there are large numbers are given to you, large patterns. You take a smaller number, try to find a value and then generalize to larger numbers. It is not there in a very specific module as such. We will be taking up a more such sums later on. There are a lot of sums which have come in the CAT which have pattern in it. We will take those and then try to study those. again a very common type of sum which can be solved easily with. So whenever you have variables in the question like this, your all PQ are variables and the answers are constant. Here the answers are constant. Okay. Even if the answers are variable, you can put the values. So whenever you have variables, substitute values for the variable, simple values. So maybe I can put P equal to 1, Q equal to 2, R equal to 3. I may even put P equal to 0, Q, I'm just trying something out, R equal to Q to 1, R equal to 2. I can't put same values. Why can't I put same values? Because then denominator becomes 0, P minus Q becomes 0, Q minus R becomes 0, R minus P becomes 0. I can't put. So I can put either of this. So I think the second one could be easier. I'm not trying to, let's try it out. P0, Q1, R2. If I put that, what do you get? First one, 0 plus 1 upon 0 minus 1 will be 1 upon minus 1. Minus 1 basically. Q plus R, 3 upon Q minus R minus 1. Right? And last is R plus P, which comes to 2 upon R minus P, 2. So sort of you will get the value and then you can work on the answer. Right? So I put this again. I put PQR. So PA, I mean you can put either values and try it out. I'm trying with first one. P0 and Q1. So 0 plus 1 upon 0 minus 1 will give you minus 1. Okay, then Q and RS 1 and 2. So 1 plus 2 upon 1 minus 2 should give you minus 3. And then you will get R plus P upon R minus P. So which give you 2 upon 2, which is 1. Or if I take the first value, I'll just check the first value and then you once you get that, this is you get the value of L, M and N. Now substitute out here. What is L? L is minus 1 into M is minus 3. What is M? Minus 3 into N is 1. And what is N? 1 into L is minus 1. Substitute 3 minus 3 minus 1. You will get the answer is minus 1. So you get the answer the option. Technically you will get the answer even if I put P1, Q2, R3. Suppose I put this. I'm just giving you an example. Like what is P plus Q? 3. And P minus Q is minus 1. Q plus R 5 and Q minus R is minus 1. And R plus P 4 and R minus P is 2. So you get basically minus 3, minus 5 plus 2. Substitute out here in LM. So minus 3 into minus 5 plus minus 5 into 2 plus 2 into minus 3. So this becomes 15 minus 10 minus 6 will give you minus 1. So either way you will get minus 1. So put substitute values which are easiest to solve and which can easily calculate and get the answer. That's what you need to do. Put substitute values which are easiest to get the answers to. So again, a similar approach as before, what we had done in the previous hours, a sort of similar approach. If I take number 7, so it is like 256. I can't go to 250 CS6. So it goes with the same approach which we did previously. Remember, it's 2016 terms, a very large number. So what happens when you do have a large number? Try to find a pattern with the smaller numbers and see how it works. So try to work with the smaller numbers, see the pattern, and then see how to work. That's how it's general. Always is generalization. A similar concept you will keep on applying again and again. And the moment you keep on applying the same concept again and again, it becomes easier to solve. That's how it works. So you need to be able to try and work on a similar concept. So here when I say 7, 2, 3, 10, and they say doubles every second. So next second becomes 14, 4, 6, 20. And again doubles again every second. So 28, 8, 12, 40. So which numbers are closest to each other? You can clearly make out an 8 and 12 are closer to each other than others. The others are going far away and far away, the difference. So 8 and 12 are closest to each other. So automatically you can make out the answer is B option, B and C. So again, what I'm doing is I'm generalizing the pattern, starting with the smaller numbers and taking the bigger numbers and generalizing into a bigger value. So I started with 7, 2, 3, 10, double and so on. Put 2, 3, 1, 2 sets and then see which numbers are close. You can clearly make out 8, 12 are close, difference is only 4. But for others the difference is much higher. This is 20 difference, this is a much higher difference, 28. So automatically difference becomes bigger and bigger. So I'm just trying to find a pattern with smaller numbers. I can't calculate for 256. So therefore, you keep on trying to figure out for smaller numbers and going about it. Right. Yeah, Jinesh, you can use that approach also. It's a little on a complicated stuff. Try solving this, but the approach is similar to what we did before. But anyway, try it out. again variables given out here and options are constant, but you have to assume values. When you assume values, it has to satisfy the constraint. That is the key. When you assume values, it has to satisfy the constraint. Okay, let's try to work on. Right, BM is, let me 5, I take AM as 6. That's what I take. BM as 5 and AM as 6. Now BM is also equal to A1. So I can say A1 is 5. I'm taking a difference of 1 because it's saying common difference is same. So I can take A2 as 6. A1 is 5. So 2 becomes M. So we can make out that M becomes 2. And we know BM is 5. I mean B2 is 5. So the common difference is same. So B1 becomes 4. Common difference is same. So B1 becomes 4. I repeat this again. I started with taking BM as 5. So your AM is 6. So BM is 5, AM is 6, and BM is equal to A1. So that means A1 is also 5. If A1 is 5, A2 is 6. I'm taking common difference is 1. So M becomes 2 because AM is 6. So A2 is 6. So M is 2. If M is 2, which means B2 is 5. BM is 5, so B2 is 5. So B1 is 4. Common difference is same. Now we want B1, BN 7 and AN 8, which comes at A3, A4, and if you look at B3, B4. So you can make out A4 upon B4 is 8 upon 7 satisfies. A4 upon B4 is 8 upon 7 satisfies. So you can make out N is equal to 4. You can make N equal to 4. And they have said C4 is B1. So C4 comes as B1 here, 4. Common difference is same. So C3 will be 3, C2 will be 2, C1 will be 1. So ratio of A1 to C1. Now what is A1? 5. C1 1. So it becomes 5:1, which is A option. That's the answer. A little difficult. More application, more substitution, but logic is the same. You assume values and then try to solve. You don't try to calculate mathematically. It's very difficult to solve mathematically. It is easier to look at the values and then try to put the values as such. I repeat this once more. So BM is 5, right? So and BM is A1. So it means A1 is also 5. So A1 is 5, BM is 5. Now A2 is 6. I have taken difference is 1. So A2 is 6 and AM is 6 we have taken. So 2 becomes M, which means BM, B2 will become 5. Since the difference is same, common difference, so B1 becomes 4. Now we want AN7 and BN8. BN7, AN8, which comes at 4. If you look at A4 upon B4 is 8 upon 7. Right? So we get NS4 from there. Once you get NS4, we know CN is equal to B1. That is C4 is equal to B14. Common difference is the same. So C3 is 3, C2 is 2, C1 is 1. So ratio of A1 to C1, A1 we know 5, C1 we know 1, we will get ratio 5:1. That will be the answer. So what we have done, we have taken similar concept sums today. One is we have taken these multiple. We will come across with multiple very common, often very good approach to solve. Second, we use something called assuming values. Whenever there is percentage of options, assume values and try to get the answer. Third, we use pattern formation, try to generalize, take smaller numbers. Whenever there is large numbers, try to look at smaller numbers, generalize and try to get the answer. Fourth is putting values for the variables. Put simple values for the variables and try to get the answer. Fifth, again generalized. Look at the smaller numbers because you have 256 here is a big number. Look at the smaller numbers and you can generalize and get the larger numbers. Right. And last, again variables. So you have variables out here, substitute values for the variables based on the constraints given to you, and you can then look at get the answer. Right. I hope it was useful. We will come every Wednesday and try to help you with some maths tricks and terms that will help you to solve things faster. Instead of using mathematical approaches of trying to solve lengthy sums, We'll look at simple techniques to solve, and this will help you to solve sums faster in any of the aptitude examinations, right? Fine. So good night, and we will see you again in next class. Thank you.